In this video, I will review hypothesis testing. The first example involves the z-test for a population mean mu. The problem states the following. A local bookstore owner claims that on average, customers spend at least $25 per visit. A market researcher suspects that the average might actually be less than $25. To investigate, a random sample of 40 customers is taken. The sample shows on average, customers spend $22.80 with a standard deviation of $6.50. Test the claim at alpha 0.05. First, we want to determine if the z-test will be used. In this case, we're given the population standard deviation, so the answer is yes. Next, we want to state the claim. So the claim is that the mean is less than $25. After, we want to determine the null hypothesis and the alternative hypothesis. Since the mean is less than $25, that's an H sub 1 or alternative hypothesis. It has the less than sign. H naught always has the equal to sign, so mu equals 25. Since H sub 1 has a less than sign, it's a left tail. So we shade in a left tail and we look up the critical value. We can use a tail. So it's one tail, right? So one tail test 0.05 and go down to the z value, which is 1.65. But since it's to the left of 0, we make it negative 1.65. Now we need to calculate the test point. The population mean is 25. Sample mean is 2280. Sample size is 40. Population standard deviation is 650. We plug it into our equation. I like to use parentheses when typing in the value. We have 22.8 minus 25 divided by 6.5. That's divided by radical 40. Negative 2.14. If you have a graphing calculator, there is a built-in function that we can use. We press stat, we go to test, select z-test, select stats, enter the data, 25, 6.5, 22.8, 40, less than. The result is z equal to negative 2.14. We now want to compare the test point to the critical value. It's to the left of it and it falls in the critical region, so we reject H naught. Since we reject H naught and the claim is H sub 1, we say there is enough evidence to support the claim. We also could perform the z-test using a p-value. In this problem, it states a wildlife biologist claims that the average lifespan of crows in California is 12 years. A group of ecologists believes that this average may be different due to urbanization and environmental changes. They collect a sample of 30 Southern California crows and finds that the average lifespan is 10.9 years, with a standard deviation of 2.4 years. Using alpha equal to 0.02, test whether the mean lifespan differs from 12 years. Apply the p-value method. Since we are given sigma, we can use the z-test. The claim is that the lifespan differs from 12. That means that mu is not equal to 12. So H sub 1 is mu not equal to 12. H naught is equal to 12. We next compute the test point. In the problem, mu is 12, the sample mean is 10.9, sample size is 30, population standard deviation is 2.4. We plug this information into our test point to get negative 2.51. Now, to find the p-value, we have to look up the tail area of negative 2.51. We can use the normal distribution to do this. We have negative 2.5. 1 gives us an area of 0.006. So now we can use that area to calculate the p-value. Remember, if the test has one tail, the p-value is equal to the tail area. If the test has two tails, the p-value is 2 times the tail area. Well, if we go back to the claim, since it's not equal, this is a two-tailed test. Thus, we have to take the tail area of 0.006 and multiply it by 2 to get 0.012, and that is the p-value. Once we have our p-value, we make our decision. If the p-value is less than or equal to alpha, reject H naught. If the p-value is greater than alpha, do not reject H naught. Well, the p-value is 0.012. Alpha is, I believe it's 0.02. Let's double check. Yes, but it's still less than alpha. The p-value is less than alpha. We reject H naught. Thus, there is enough evidence to support the claim because the claim is H sub 1. Now, an alternate way of calculating the p-value is when you have a graphing calculator. Once again, you can use your built-in z-test function. Press that, go to test, select the z-test, and you enter your information. Mu is 12, sigma is 2.4, x bar is 10.9, and is 30. In this case, it's not equal to, so we calculate. We do calculate our test point, but right below is the p-value, which rounds to 0.012. Now we have our third example, which is for the t-test of the mean, mu. We have a problem. It says a transportation agency claims that the average commute to work for people living in Southern California is 35 minutes. A researcher believes that the actual commute time is longer due to recent traffic congestion. To test this, the researcher collects a random sample of 10 residents and records their commute times in minutes. Here we're given raw data. Using alpha equal to 0.01, test the claim. Well, here we want to ask ourselves, will the z-test be used? The answer should be no, because the population standard deviation, sigma, is not given. So when sigma is not given, we have to use the sample standard deviation. Thus, that means we will be using the t-test. So we state our claim. The claim is that the mean is greater than 35. That's an H sub 1 statement. H naught will always be the mean equals 35. So we have a right tail test So we shade in the right tail. We have to find a t-value. So to find the t-value, we need to compute what's called degrees of freedom, which is n minus 1. Since we have 10 data values, we have 10 minus 1 is 9. To look up the critical value, we need to, first of all, let's find our alpha. It's 0.01. So we have a one-tailed test, alpha's 0.01, and we go down to 9, 2.821. That's our critical value. Recall the critical value separates the critical region from the non-critical region. Now we need to calculate our test point. In this case, since we're given raw data, the simplest way to calculate our key values is to use our calculator. If we have a graphing calculator, we can do that easily. We press Stat, Edit. I like to clear any old data from the calculator. And then I enter the calculator in L1. That stands for List 1. Once it's entered, we press Stat and we go to Calculate. Select option 1, hit Enter. Make sure L1 is in the list row, and then just press Calculate. The sample mean is 38.8. Sample standard deviation S, 2.94. So we know the mean is 35. Sample mean 38.8, sample size is 10, S 2.94. We plug that information into our formula to get 4.09. Now, if you have a graphing calculator, after you enter the data, you can actually calculate this value directly by pressing Stat, going to Test, Option 2. Instead of selecting stats, you want to select data. You have to type in mu, in this case it's 35. You want L1 because that's where our data has been entered, and we need greater than. Hit calculate, and you can see that T is 4.09. 4.09 is to the right of our critical value. It's in the critical region, so we reject H0. Since our claim is H sub 1, we state there is enough evidence to support the claim. And then finally, our last example is the z-test for a population proportion. Our example states the following. A university researcher claims that 12% of college students in California major in political science. Curious about whether the proportion is still accurate given recent shifts in student interest toward environmental science and data analytics, a graduate student surveys a random sample of 300 students from public universities across the state. In the sample, 48 students report they are political science majors. Alpha's 0.10 tested claim that the political science majors differs in California from 12%. Well, the claim is that P is not equal to 12%. We write that as a decimal, 0.12. Next, we determine the null hypothesis and the alternative hypothesis. Well, since H sub 1 has not equal to, so that means P not equal to 0.12, which is our claim, is H sub 1. H naught always has equality. P is equal to 0.12. This is a two-tailed test, so we shade in two tails. And we look up the critical value. It's two tails alpha is 0.10. Two tails alpha is 0.10. Remember, when we test for P, it's always a z-test. So we go down to the last row and we see it's 1.65. The critical values are negative 1.65, positive 1.65. We have to now calculate our test point. So X is 48, N is 38. We take our sample proportion, P hat, it's X over N. 48 divided by 300 is 0.16. P is 0.12. Q is 1 minus P. 1 minus 0.12 is 0.88. And we plug this information into the formula. Let's type it in. So I like to use parentheses. We have 0.16 minus 0.12 divided by the square root of 0.12 times 0.88 divided by 300, and that gives us 2.13. Also, if you have a graphing calculator, there is a built-in function. You press Stat, go to Test, and we go to number 5, the one proportion z-test. We enter. At the very top, you want to type in 0.12. X is 48. N is 300. And our claim is not equal to, so you select not equal and then calculate. And you can see Z is 2.13. And that will fall in the critical region because it's to the right of our critical value. We reject H naught and we state that there is enough evidence to support the claim. So that's a review of all the major tests that we covered for the hypothesis testing of one sample section. Thanks for watching.